Hello everyone, my name is Lai Olson. I am the acting director and data scientist for the Measurement Lab project. Measurement Lab is a fiscally sponsored project of Code for Science and Society. I am recording this for the Africa Digital Skills Conference of 2022. And you can follow along with this presentation by going to this link, and then later on we'll be doing a tutorial for which you can use that link. So pause the video, go ahead and grab those links because we'll be referring to them later on. But today my goal is just to give you a sense of what MLab is, what our data is, how it is generated, and what you can do with it. There are extensive amounts of information that I could go into that I will not today, so this is very much an introduction, but I do hope it piques your interest and gets you started with everything that MLab data and our MLab project has to offer. So there's my introduction again. First, I'll just start by giving a sort of history of MLab and why we started. We were founded in 2009 to answer this sort of primary question: how do we measure internet performance at scale? Of course, at that time, I think YouTube was founded in 2007, 2008. It was an earlier day of the internet. However, it was growing at a rapid pace, and the question was, how do internet researchers keep track of how the internet is evolving, and how do we do so in a way that scales across the size in which it was growing, and it still is today. So the founders thought about, how do we do this? How do we also combine all of these different key players that all have an impact and have an interest in how the internet performs? How do we connect all of these key players to answer, again, this question of measuring internet performance at scale? Fast forward, I guess 13 years, and which is crazy. And here we are. Today, MLab provides an open, verifiable measurement platform for global network performance. We host one of the largest open internet performance data sets, and our mission really is to measure the internet, save the data, and make it universally accessible and useful. And so the way we started with this question, there were a lot of different ways we could have gone. There are many ways to measure the internet. Certainly there's no one or right way, but the way that we have chose to is with an interest in providing this data for open, free and open access, such that anyone can benefit and use the data, but specifically an interest in providing those who make decisions about how to measure the internet, meaning policymakers, academic researchers, citizen scientists, digital inclusion advocates, network operators. So many groups have an interest in understanding how the internet is evolving, and the goal of our data is to help provide access to metrics that reveal that. So that's the high level sort of goal of what we're doing. How we practically implement that is described by a number of ways, starting with our platform. So currently we run a platform of about 750 servers. These servers they host what we call measurement services or experiments, and they are proposed by third-party researchers, often academic, but not always. And on each of those servers, we host these experiments, and we place them in what we call interconnection points, which are essentially 2 hops away from a user's network, from your network, from my network. They go outside of the access network and into data centers where internet service providers peer with one another. Peering is essentially a way to exchange traffic between different networks, different providers, and we place our servers in those locations to measure what we think of as the inter part of the internet. That said, starting in 2022, this year, we have started to provide servers in cloud networks as well. So our platform is continuously evolving, and that 750 number is actually referring to our platform, including those new virtual nodes. So when a client, meaning a user, runs a test, any test that we provide, which we'll get into what those are, but any test, what happens is it goes from our computer, the user's computer, through their access network, through their transit ISP, and to an MLab server. It tests what we call it against that server. And that server and the client both spit out a result that's then archived in our public database and shown to the user, and which we'll talk more about. But the servers are a fundamental part of how we measure the internet because they provide the vantage point from which we are able to measure. And that is, of course, met also with where the clients test, which we'll also talk about where those come from. So on the client end, to get the data, again, users have to run tests. We actually only support active measurement services, meaning that tests have to be initiated by a client. So like I mentioned, we host multiple measurement services. However, one of our most well-known ones is what we refer to as Network Diagnostic Tool, and that is embedded in the Google search integration. So whenever you Google something along the lines of speed test or how fast is my internet, NDT, Network Diagnostic Tool, is what pops up, and you are able to take a test directly from the interface, and a number of other integrations that exist as well that integrate NDT and other MLab measurement services. But to tie back to the last slide, so what happens when I click this test, it actually runs a measurement to the server that we host and then back as well. So it's measuring the download and the upload. And again, that data is then archived on our servers, pushed through our public pipeline such that it is annotated to make sense of what it is. It's also archived in sort of its raw format, but most people will want to access it in BigQuery, which we'll actually do later on in this tutorial. So I just mentioned Network Diagnostic Tool and how it is integrated into the Google search integration. And so I'll talk more about that as it is actually our most popular and most widely used data set and what we'll be talking through how to access today. And Network Diagnostics Tool is a throughput test. It more specifically measures the single stream performance of bulk transport capacity. So what is that? Great question. Essentially, when you open up a internet connection, you're opening up what we call streams of data. And it is true that actually a number, or the most common modern browsers will open a number of streams. And so NDT is actually not doing that. And so in that way, it's not a sort of what some consider a classic speed test, because other speed tests will often open up more than one stream. NDT is instead trying to measure just one of those streams to understand how reliably it can transfer data. It's kind of like if you have a highway, you're measuring one single lane and trying to understand how gravelly it is. So NDT is often called a speed test. The actual term of speed is not super well defined. There are a bunch of different ways you can measure speed. This is a way to measure throughput and speed in a way that again, doesn't try and measure the whole link, or it doesn't try to measure multiple streams and you're not trying to see how much you can fill up the highway, but rather how effectively you can transport packets across one single lane of that highway. So again, NDT is the sort of most popular test that we offer. And over the years, we've been able to collect, I thought I had a slide that I don't. But essentially, over the years, we've been able to collect on average about 3.5 million tests per day, and something around 10 billion rows of NDT data have been collected over the life cycle of the project. So it's a lot of data, and it's been collected, all over the world. This is getting into the sort of specifics of what we're measuring. Again, bulk transport capacity being the rate that a link can deliver data with TCP. The single stream performance is indicating that it's only one TCP stream that's being measured. This is in the weeds, which matter, but for our purposes are just details that you should have in mind when you're thinking about what is it actually measuring, and being able to define that to your users, to people that you present your data to, that it's a specific kind of internet measurement. So the other part of our platform to note is that actually every single time a test is run, it runs what we call sidecar services. These will only be interesting to folks with a little bit more networking expertise. If that's you, great. Just letting you know this data exists. If it's not, don't worry about it. And in later, tutorials, we can come back to it. So just again, touching back to the sort of life cycle of a measurement. So we'll actually, when a client runs a test, for example, in the Google search integration of NDT, a client will run a test. It will contact what we call the locate service, and it will tell the client where to send, what server to go to. It's going to run that test, and then again go into that data will go into the data pipeline and be popped out into BigQuery for analysis by data users, such as yourself today. Again, here's our infrastructure map, 750 servers globally. I will show you later in this presentation how to access this map in case you are wondering if we have servers in a specific location. And there's some other stats about where we are represented. And this is getting a little bit into the specifics, but this diagram illustrates essentially how in each metro or city we break down the placement of our servers. So within every metro, there are different what we call sites, and within those sites there are servers. Again, these are kind of into the weeds of the specifics, but can be useful if you're trying to describe what exactly it is you're measuring. Okay, so with that introduction, I wish I could ask if there are any questions, but I am recording this asynchronously. With that noted, I will provide my email at the end of this presentation and would be happy for you to reach out. But with that, we'll get into more of those details as well as we go through the tutorial. There is a tutorial linked here if you didn't get the link at the top, and I encourage you to open it up. And the first thing to note is that you will need a Google Drive account to make a copy. So if you need to pause now, take care of that, to sign in. If you already have one, go ahead and do that. I'm going to open that up myself. And what this links you to is what we call a Colab. You might already be familiar, but in case you're not, it's what we call a notebook, which allows you to run queries and use Python and really examine data all in one place. And it's an incredibly useful tool for data analysis. And like I mentioned before, our data, meaning MLab data, is archived in what's a tool called BigQuery, which is essentially a way to access really big data sets using SQL. And then again, a Colab or a Jupyter Notebook if you prefer, but we're using Colab today, will help you access that data through using Python and then a combination of Python and SQL. So if you don't have experience in either one of these, that's totally fine, but you will just want to sort of copy and paste and find your way there. If you do have experience, that will give you a little bit more of a head start, but also we'll be going through, sort of the specifics of how one accesses different aspects of our data. So that will be the lesson today. Actually, the very first thing that you're going to want to do is on this getting started section. To get access to the data, we have what we call the discuss list and the discuss group, and getting access to that is going to be your first step to all of this. So to do that, you'll go to the link that is at the top of the Colab, this NDT data, or sorry, visit this link for quick start instructions on getting access to the MLab data. And you're going to go into that and sign up for the MLab Discuss group. It's super easy. It shouldn't take, more than maybe a minute. But with that, you'll be able to be authenticated into the BigQuery access list, and that's how you get access to our data. Again, it's all free and it's open, and that is a fundamental part of Measurement Lab's mission. So once you do that, you might want to actually refresh the Colab just to make sure that it's going to recognize you as having access. I don't know, sometimes it's just better safe than sorry. So once you do that, then you're going to go ahead and run these utilities. And the first time, so we're going to go through this query. So, don't be scared by it yet. But before I explain what is happening here, I'm actually going to run the query to demonstrate how you will then authorize yourself to get access to the data. So when I run this query, it's going to say, please visit this URL to authorize this application. So I click on that link. And I, choose my account. You might have multiple. Choose the one that you signed up for the Discuss list. And then you authenticate it, continue. It's going to give you an authorization code. You copy it, you move over here, and you copy it into this box. So again, I clicked on this link. I identified that I wanted to authorize this application to be run. In this case, it's Pandas Google BigQuery library. I'm going to copy this code and enter it here. And I'm just going to press enter. And that's going to allow this query to essentially access BigQuery using your permissions to the Discuss list. It's going to use that to then get you access to the data and to run this query. So taking a step back, or taking a step forward, I guess, that's just the authentication part. Now I'm going to start talking about what's going on here. So again, NDT is measuring essentially a throughput calculation from our servers. For the download, it's sending data from our servers to the client, and for the upload, it's sending data from our client, meaning our computers, to the MLab server. So we get download and we get upload tests. Download tests tend to be the more sort of popularly queried, but it's important to remember that the way the internet is structured, you do need both. You do need to be able to send and receive data. So the queries we are going through today are download specific, but remember that there is upload data, and it can tell you significant information about connectivity if you look at the upload data as well. Okay, so the download tests are what a user is getting from, again, the server to the client. And then when that data is put into BigQuery, then we essentially have this just like giant pool of download and upload data. So in these queries, we're actually going to go through getting the download tests from a given city at a given time. Oh, and this should not say Baltimore, Maryland. It should actually say Nairobi, Kenya. So this query, our goal is to get all of the data from Nairobi between the dates of October 3rd and October 10th. So if you're familiar with SQL, this is using the where clause and essentially just specifying exactly what dates and what location we want the data from. These are all fields that we annotate the data with, so that you know where and when the test was taken from. One thing to note here is that the way that we geolocate the data is actually using the IP address. So whenever someone takes a test, we are given their IP address, and we use that IP address to annotate the data using what is called the MaxMind geolocation. And so essentially there's an organization called MaxMind, and they connect IP addresses with geographic locations. The level of accuracy is not great. There is research around that. I can feel free to reach out if you're interested, but generally I say to not to trust nothing lower than the city level, and frankly sometimes the city level is also not as accurate. So sometimes you do want to rely on something with a larger granularity than the city level. It's not always the case that it's inaccurate, so we do typically use it, but when you're just trying to get a broad scale trend, it can be acceptable. If you're wanting to do more fine-grained analysis, such as, in the US we have the concept of a census block, but street level essentially, then you will not want to rely on our geolocation. But that said, I can talk more about other solutions. But if you're just looking for country level data, or again, bigger city, or bigger less fine-grained granularity, our data is really good at being able to tell you how those types of regions change over time. So all that to say, this part in the query is going to identify where you're interested in getting data from. So the next, so in the select clause, then we're just specifying what information do we want to get returned back to us. So within these sort of parameters, what kind of data do we want to get back? So I'll just take these one by one. We're looking at a field called the UUID. The UUID is the unique identifier for the test. So every test that's run is given a unique identifier that you can then correlate to other tests, or other tests that client ran at the time. So calling back to the slides, we talked about how we also run a traceroute test and other sidecar services. This UUID allows you to connect those tests with the other measurement services that were run for that client. You can also get the test time, of course, meaning when the test was taken. And then the mean throughput, megabits per second is what this stands for. That's going to be your download speed. So that's going to be the average of the data. That was the way NDT calculates it is it's the average of the data that was able to be sent over the entire test period, which is 10 seconds. So this is essentially what you would refer to as the download speed, typically acknowledging again that there are many different ways to measure speed. This is the min RTT, meaning the minimum round trip time. So the minimum amount of time it took for data to be sent round trip between client and server, and loss rate, meaning at what rate were packets lost. I encourage you to look into these metrics if you're interested, and to find out more about their definitions. A lot of times folks will just use the download speed, although something that Measurement Lab tries to have conversations about is how you can have a really high bandwidth and still have a crappy time on the internet. And sometimes these other metrics, or just these other metrics, can help you parse maybe what's going on. And then the other thing I would say is that, as I've mentioned, there are other ways to measure speed. It's often useful to compare the results you're getting with NDT with other speed test results to get a sense of what these different methodologies reveal about connectivity. So that's zooming out a little bit, but zooming back in, we have our download speed as interpreted to, or as defined by mean throughput, megabits per second, min RTT, and loss rate. And that's essentially, just getting the actual sort of test results. Then we get into the annotations. So the annotations are, details or a form of metadata that tell you a bit more about that test. So it's going to tell you how it was tagged, or what city it was tagged as. So again, we just reviewed the sort of limitations of IP geolocation, but it's going to tell you exactly what city MaxMind believed that IP address was in. It's going to tell you the subdivision 1 name as and in this query we're calling it the client region. This differs based on the region or the continent or the country. So I would recommend looking up what subdivision 1 name means in the region that you're looking at. It's also going to give you the ASN number that IP address is associated with, and also the name that I should be highlighting this one, the name that that ASN number is associated with. So essentially, that's the if you are not familiar, the every network has what's called an ASN number, and it's essentially identifying it between all the other autonomous system networks that exist. And then the name is often, is in most cases associated with the internet service provider that owns it or runs it. So this is sort of analogous to whatever sort of machine readable number or machine recognized number that the client device, meaning the user, was in, or identifies the network that the user was in. And this is the probably more human readable name. So those are all fields for the client. And if you are new to SQL, just noting that these are what we call the fields and how they've been annotated in our data. And then when we say as client city, that's essentially just naming the column that it will be spit out by. So client GeoCity is kind of a clunky, column header. So we're going to say as client city to give it a little bit more readability. So again, all of these fields are actually for the client, meaning again, the user, the person, or the machine that takes the test. And then all of the rest of these are essentially, analogous, but for the server. So meaning the infrastructure that MLab hosts. So calling back to our diagram here, a lot of the terms are also applied in the fields. So, we have the server city. These are actually with more certainty, given that we know where those addresses are, or where those servers are. The server site is referring to, what site within a metro that the test result tested to. So client runs the test, runs against the server. Server site is then identifying which one of the sites that it tested to. And again, calling back to this diagram, that's decided by our locate service. Not maybe super terribly important for your analysis, but if part of the analysis is understanding how the test works, that is how the server is chosen. And then again, the server machine is then referring to which machine within that site was used. Here it's referred to as servers. And then you're also able to know what ASN, meaning Autonomous System Network, number, Autonomous System number was used, and then what name is associated with that number. So these are just some of the most common fields and sort of the most informative fields typically about, again, download tests from a given city at a given time that you can use. All of this information you can look at in two ways that give you answers to different questions. So the first one is the schema info. And for those of you who've worked with SQL before, you'll know that data is, sort of organized in what we call tables. And the fields are then, you're able to see them within the schema. So for example, when we see, a.uuid, we can see here that the UUID is, I don't know if this is the technical term, but a substring of the A field name. So to get the UUID, you first, because it's nested under A, you need to call a.uuid, and so on and so forth for these other metrics. So if you are basically thinking like, what else can the data, or what other fields can I pull from, you can go through in the schema and identify, what fields are available to you. The ones that we just covered, again, are sort of the most popular or often used, but there's a lot of information in here that you can also access, and you can use the schema to help you identify what's possible. You might also be wondering what the different fields mean, and for that I would recommend using this description on the MLab website, where we kind of further define what these are. So for example, here is a description of the mean throughput, which is essentially the download speed, and then how, information about how these other fields are defined. So more information in there. And then one thing to note, then we go down here and we basically tell SQL and BigQuery where we want to get the data from. This is the table, and you'll note that the first thing we'll note is that it's the download table, and that just is specifying, again, only download tests, only tests from the server to the client, server sending data to the client. The other thing you'll note is that there's this prefix called unified, and I don't want to get too much into the weeds of this today, but essentially there is a blog post that kind of digs into describing how NDT we've hosted since very early on in the project, 2009. But over that time, we have released different versions of the protocol. And so all of those are stored to keep continuity of the data. All of those are stored in the unified downloads, but they are essentially different versions of the same tool. So you can kind of think of it as, a different tool, the same tool with different sort of configurations throughout time. If you are interested in these details, one of the biggest changes was the TCP congestion control algorithm that that NDT uses to deal with congestion. That's all described in these blog posts. The important part that you should remember is essentially that this is, if you're just trying to access the data over time, it's that all of this data, if you want to use data since the beginning of the MLab project, the unified downloads table is going to be where you go. If you want to use data from a specific protocol, if that matters for your analysis, then you'll want to go into the more specific NDT5, NDT7 tables. Again, I would just suggest, if you're just trying to get your hands dirty with the data, this is the table to use. But for that more specific analysis, then I would read more about the evolution of NDT here. And of course, feel free to reach out. And then this last bit is just going to order the test by test time. So because I authenticated, I'm now able to see, the top of the data that's split out. Maybe I'll also run in a new section, df.info, to get a sense of what it's returned back. So it looks like we got quite a bit of data back, and we got, all of these different fields as well. So 14 fields or columns total. So that's just a walkthrough of how you can get the download test from a given city at a given time. I hope already this illuminates a lot of different ideas about what you could do with the data. There's, every different region has had a different internet evolution, and so breaking down the tests from say this year and comparing it to the evolution of tests from this year, and then maybe correlating it to what about your region in terms of infrastructure, or during COVID we saw, of course, an uptick in usage, and so how did that affect the performance, and with all of these there's always considerations to be made in terms of one thing to note is that people, all of our tests, like I mentioned, have to come from people testing. So why are people testing is sometimes an interesting question. Are they testing more because something's going well? Sometimes that's not the case, right? Sometimes we test because we think something's going wrong. So there are different, sort of biases to keep in mind, but looking at it from if you have a question about how has the internet evolved, NDT data is a really, really good, informative, data-rich place to start because there is so much of it typically. The other question you might ask, and I won't go through this, I don't actually need to go through this in much detail because a lot of it is the same, but another question that you might ask is, how many tests, or give me information about tests that we're testing towards a given location. So these are all based on, the tests that were taken in a different, or in a specific region, in this case, Nairobi. But, what if I want to know how many tests were taken towards these servers in Nairobi? So that could include tests that were taken in Nairobi, but they could also include tests that were taken further away that were directed there because that was the available infrastructure. So in that case, what I would do, and again, sorry, these should actually read, I'll just change this right now. Hopefully, so by the time you look at it, they will be correct. But okay, sorry about that. So this is looking at all of the tests that were directed towards our server in Kenya. So how did I find that out? Up at the section with all of our links, there's a link to the infrastructure map for the MLab infrastructure. And on it, you can see all of our servers. And so again, I wanted to know what server was either in or closest to Kenya. We have a set of servers in Nairobi. I click on this and it's going to tell me the prefix for all of the servers there, as well as the different machines that are available. So when I wanted to then select all the tests that were directed towards a server, I was able to use this prefix NBO, and I'm gonna go back to my query. And I'm just saying a server site like NBO %, which is going to give me the servers that essentially start with NBO. And so then here we have a lot of the same fields, perhaps we have a lot of the same questions, and it's going to give me, a slightly different data frame back because it's, again, not giving me the tests that were taken in Kenya, but the tests that were directed towards the MLab server in Kenya, which is a slightly different question. The last example that I'm going to reference is, again, well, not again, I don't know if I said this before, but thinking about how many tests were taken and how that can sort of inform your analysis. So for example, if you got if you were looking at the median of tests in a specific location, and maybe it was really low or maybe it was really high, but then you should then think, well, how many tests is that coming from? Is that a representative sample? Sometimes it is, or a lot of the time it is, given the sort of volume of our data, but sometimes it's only 10 tests and you really can't tell that much from 10 tests. Actually, I would say that's probably the minimum, and it would depend on, over how much time or how long, those 10 tests, like one test per year over 10 years, again, not very informative. So looking at the amount of tests in an area can often be super useful. And so this is a query that's looking at how many tests per day. It's also getting into something that's a little more detailed about which congestion control algorithm is being used. I provided that as an example in case that's something that you want to look at, but if not, the important thing is to note that NDT7 uses BBR, and so for the most part, this is indicative of our current tests per day globally. As you can see, tests that use cubic, which is what NDT5 uses, are significantly less. So this query breaks down and then graphs. I won't get into how to break this down, but essentially plots then, how many tests per day were run during this period of time, and that's globally. So this one does not have a geographic filter. So that's an example of, just how many, tracking again, just how many tests per day. You would then want to break it down geographically if you were looking at a specific region. But this can often reveal really interesting insights into sort of why people take speed tests to begin with. Something that we observed with the Facebook outage that happened in the fall of 2021. There were those terrible 6 hours where we couldn't go on Facebook or WhatsApp or Instagram. And people were, it looks like, we hypothesize, going to likely our Google search integration, but also other integrators of network diagnostic tool, and saying, is it testing their speed? And I think the question there often is, is it me or is it the service? So is it something with my internet? Is my internet going to return a super low number? Or is it, if I get a super high number back, I might assume that then it's the application that I'm trying to use or the website I'm trying to use. So there's a lot of nuance there, and there's a lot of generalizing in what I just said. But clearly here you can see the spike in the number of tests per minute clearly reveals that whatever the reasoning may be, more people take speed tests when there is something, sort of at large wrong with the internet. And so this is a good example query to break down if you're looking at, a specific time period, a specific event. We think a lot about different internet shutdown events. So looking at, how many tests on average are run usually during a specific time period, and then how many tests are run during a shutdown event. And if we can notice a dramatic decrease, that might suggest that less people have access to run the test itself. So there's different questions you can ask with test count, but it also can just really inform, how much confidence you have in the data. And so I would recommend using this query as just a resource. I went over the first one in detail. There's a lot of other details in the subsequent queries and the examples of the plots. But I hope that this sort of piqued your interest in what the data can do and what's available for free and open access, how much of it there is. If you're interested in getting involved with MLab, there's a bunch of different ways. I think the biggest way is probably just to use it and to share your analyses with us. I also am realizing that my email is not on here, so I'm going to add it here. Please reach out. I, wish that this were a synchronous event so that I could, answer questions live, but I'm happy to answer any if you just reach out. There's my personal email, and good luck. I mean, there's so many interesting things that you can find in internet measurement data generally, but in the MLab data specifically as well. If you're new again to Python, SQL, and data analysis, feel free to also look at resources describing SQL and Colab, and those might also help you. And then if you're new to internet measurement or networking, there's also, I would also maybe think about, looking into resources about how TCP works and such. Just to say, those are also topics that kind of inform how you use the data. But then for the measurement lab specific things, feel free to look at our website for the documentation, and also, again, reach out. So thank you so much for having me. Thank you for putting on this event, and I hope to hear from you, and I hope that the data helps inform your research.